Alright, so in today's tutorial, we want to look at a brief introduction to statistics. So to begin with, what is statistics? Statistics is the science of collecting, organizing, analyzing, and interpreting numerical data to understand a phenomenon for effective decision making better. Statistics is a science because it involves an experimental study or an observational study. These are the two main research studies in statistics. An observational study, data is collected without any attempt to manipulate or influence the outcome. That is, the researcher may simply observe the subject and record data based on the observation. However, with the experimental study, data is collected with an attempt to manipulate or influence the outcome. That is, the researcher may deliberately impose one or more experimental conditions on the experimental unit in order to determine their effect on the response. So let's take an example. Let's say an administrator in public health might be concerned with the number of residents with COVID-19 during the Christmas holidays. This is going to be a typical example of an observational study because in here, the administrator is just going to record the health status of this resident based on their past activities during the Christmas holidays. But let's say, suppose the administrator intends to impose some conditions on the resident. Let's say he will allow some of the residents to go out and he will let some be indoors and later record their health status to see if they have contracted the COVID-19 virus or not. So in that case, we are going to have an experimental study. But in here, because the administrator is just going to observe the health status of this resident based on their past activities, this is going to be a typical example of an observational study, right? So let's take another example. A researcher in the field of education might want to know if new teaching methods are better than old ones. So this is going to be a typical example of an experimental study because for us to decide whether the new teaching method is better as compared to the old teaching method, we are supposed to impose some conditions on the experimental unit, right? We are supposed to assign some student to the new teaching method and assign some student to the old teaching method, later compared to see which of the methods is best, right? So these are the two main. There's just some example of the experimental study and observational study. Now the next thing is, what do statisticians do? So statisticians work in many fields such as education, marketing, psychology, or any other field that requires the collection and analysis of data. So their job description include the following. One, statisticians decide what data are needed to answer specific questions or problems. And this is very key because as a statistician, you don't just decide to use any statistical method to answer any specific problem of your own choice. You are not supposed to do that because you can't just decide to do an over maneuver regression analysis or let's say time series analysis based on your own choice or preference. But you have to know the structure of the data that you have at hand. It is the data that you have at hand that will drive you or that will inform you to know the kind of statistical technique you're supposed to adopt to answer a specific problem. So as a statistician, knowing the structure of the data set is very, very key to enable you to know the kind of statistical technique you're supposed to use to answer a specific problem. So this is a very key job description. The next is that they design surveys, experiments, or opinion polls to collect data, right? I think this is self-explanatory. The next is that they develop statistical mathematical models to analyze data. It's not only just about you knowing the structure of the data set. Sometimes you may have a data at hand and there's no existing method or there's no existing statistical method that you can use to answer that kind of data set that you have. So in that case, as a statistician, you're supposed to formulate or create this as a model that can be used on that data that you have at hand. So this is another key job description. The next thing is that they interpret data and record conclusions drawn from the analysis. And I think if you can record the definition of statistics, we say statistics is the science of collecting, organizing, analyzing, and interpreting data. This last description, if it is ignored from your analysis, then in fact you have failed as a statistician because um, in fact we have many statistical software packages that we can use to analyze data, but at the end of the day we want someone to be able to interpret the result and the output for the layman to be able to understand. And this is one of the key job description for a statistician. You're supposed to be able to interpret the output. Let me show an example. Let's say you have this output from your result. This a layman cannot understand this. So as a statistician, you're supposed to be able to interpret this kind of result that will make meaning to the layman at the end of the day. So job, what we call interpretation of data is something that's very important job description for statistician. The next thing is that they use data analysis to support and improve business decision. And I think this is another key job description because if you can recall during the COVID-19 period, it was statistics that informed many governments, stakeholders, many states governors to put certain regions and states to lockdown. It was as a result of statistics. The information that was obtained enabled certain the government and other key stakeholders to take certain decisions, right? So if you can recall, you realize that if you look at some of the bar chart and the pie chart from the World Health Organization, you realize that some of the information, you realize that some of the COVID-19 was more concentrated in a particular areas compared to other areas. So the government decided to put those cities or those states or those regions to lockdown, right? Which in the long run helped in reducing the spread of the COVID-19 virus, right? So as a statistician, apart from you interpreting the data and analyzing it, at the end of the day, you are supposed to use this to support and improve business and other governmental decision, right? So now that we know the job description of statisticians, let's move on to the next slide. Basic concept of a data set. So as I have already mentioned, knowing the structure of a data set as a statistician is a key because that is what is going to inform you to know the kind of statistical technique you're supposed to adopt to answer a specific problem, right? But in here, we are just going to look at a general overview of a data set. In our subsequent tutorials, we are going to look at the structure of the data set for some statistical methods, right? So data is very, very important in statistics because valid conclusion can only result from data which has been collected properly. And you need to know that there is no good statistical tool that can produce good results from wrongly collected data. So knowing the structure of a data set, knowing how data look like is very important in statistics. Without data, in fact, there will be no statistics at the end of the day. So it's very important we know the general overview of a data set. So this is going to be the general overview of a data set as shown in table 1. So I have my ID sit on the first column, assuming this is my Excel sheet, and have the variable sitting on the other columns, right? So these are the indexes for the variables 1, 2, 3 up to P, and these X indexes are basically the data points or values for each variable. So let me open an Excel sheet so that you can see the beauty of what I'm trying to illustrate. So in here I have the ID sit on the first column and I have the variable in here at the other columns. I have more than one variable, so these are going to be variables, right? So age, height, gender, grade. Now, when we talk about ID or individual in statistics, what do we mean when we talk about ID or individual in statistics? In statistics, when we talk about individual, it is the object on which a variable is measured in a research study. Synonyms for individual could be experimental unit, sampling unit. You can have element or subject. These are synonyms for ID or individual in statistics. These are some of the basic concepts that you may come across whilst you are studying statistics, right? The next thing is variable. When we talk about variable, what do we mean in what does variable mean in statistics? A variable is a characteristic or attribute recorded or measured about each individual. So when we pick any person here, what can we record? We can record the age, we can record the height, we can record the gender, grade. There are other many variables that we can record if you pick any of these individuals, right? So this becomes a variable, right? Now the values, you can see that for each variable it can assume some values, right? This variable can assume these values, this variable age can assume these values. So the values or measurement that the variables can assume is what we often refer to as a data. So this becomes a data. This variable can also assume these values, so this becomes a data. This variable can also assume these values, so this becomes a data. This variable can also assume these values, right? So this also becomes what? A data, right? Now the values in here, each value in the data is what we refer to as a datum. So this a datum or the data point, right? Now, if you take a close look at these variables that we have, you can see that some are numeric, like the first two variables. These are numeric, and the last two variables are non-numeric, right? So this leads us to the two types of variables in statistics. In statistics, we have the quantitative variables and we have the qualitative variables. When we talk of the quantitative variables, like the first two, these are variables that can be measured or written down with numbers. In other words, these are observations that are measured on a numerical scale. So these are quantitative variables, right? And the last two variables in here are known as the qualitative or the categorical variable. That is, these are variables that cannot be measured or written down with numbers, but can be placed into distinct categories according to some attributes. For instance, if it pick gender, it's either it belongs to the male group or it belongs to the female group, right? If you pick grade, it's either it belongs to the A class or it belongs to the B class or it belongs to the C class. Now, if you take a close look at the quantitative variables, you can see that we also have two types of them. We have one of them assuming whole numbers, and we have one of them assuming values within an interval of real numbers. So this also leads us to the two types of quantitative variables. So those values that assume whole numbers are known as the discrete variable. So a discrete variable is any quantitative variable that can assume whole numbers or can be counted. So this is an example of what discrete variable. We have other examples, like other examples of discrete variable can be, let's say, number of students in a class or the number of residents in a community, right? These are things that can be counted, right? And if you take the continuous variable, this a type of quantitative variable that can assume values within a specific range that is corresponding to the values on a real number, right? Or in a real um, corresponding to the point on a line interval, let's say that. So that is the continuous variable. So other type of continuous variable can be, let's say, volume of an object, weight of an object. These are values that can assume values within an interval of real numbers, right? Now, if you take a close look at the qualitative variable, you can see that we also have two types of them. We have one of them that involves ordering or ranking, and the other one doesn't involve ordering or ranking. So let's pick this as an example. So those the type of qualitative variable where no order or rank can be imposed are known as the nominal variable. So gender is an example of a nominal variable. Other types of nominal variable can be religious affiliation. You can either belong to a Christian community, or you can belong to a Muslim community, or you can belong to what other religion. You can belong to two of these categories at the same time. We can also look at marital status. It's either you are single, married, or divorced. You can belong to the two groups at the same time. So this is one type of the qualitative variable, that's the nominal variable. Now we can assign numbers to these categories, these characters that we have here. I can say let M, that is male, be 1, and let F, that is female, be 0. These numbers that I'm assigning to these values, they are just for indication purposes. They don't have any real meaning. It's just to differentiate between the categories, right? Because in most software packages, it doesn't require these characters. You have to basically use some coding, some numbers to be able to make it work. So the numbers that we normally assign to categorical variables is just for identification purpose, just to differentiate between the categories, right? So you have to take note of that. Now, the other type of qualitative variable is known as the ordinal variable, and we have grade as an example. This is a type of qualitative variable where the variable is classified into categories which can be ordered or ranked, right? But you need to know that there's no precise difference between the ranks. For instance, someone in A class, you can see that his or her level is different from someone in a B class, and someone in a B class, his or her level is different from someone in a C class. So there are some ordering or ranking in this kind of variable, right? We can also look at the taste of food. We can either have good, moderate or bad. When we say something is good, you can say that its level is different from something that is what bad or moderate. So that's another example of ordinal variable. We can also have place, finishing, and election. We can have first, second, third, right? And this involves some ranking or ordering. Now, another way of describing our data set is by using scale of measurement. The scale of measurement is a process of classifying data according to how they can be grouped, counted, or measured. And we have four types of them. We have the interval scale of measurement, we have the ratio scale of measurement, we have the ordinal scale of measurement, and we have the nominal scale of measurement. Now, the ordinal scale of measurement is the same as the ordinal variable. The nominal scale of measurement is the same as the nominal variable, but the interval scale of measurement and the ratio scale of measurement, we can classify them as quantitative variables, right? Right. But the main difference between the interval scale of measurement and the ratio scale of measurement is that with the interval scale of measurement, there's no meaningful zero. However, with the ratio scale of measurement, there's a meaningful zero. This is what I mean. Let's say you pick this individual age is 19. The fifth of individual's age is also 19, right? If you take the difference between this age, you have 0, which means that there's no age, right? It is meaningful. However, if you pick a variable like temperature, assuming this one is 19 degrees Celsius, this is also 19 degrees Celsius. If you take the difference between this, you're going to get 0 degrees Celsius. This 0 degrees Celsius doesn't mean that there's no temperature. There is temperature, but it's telling us how cold the weather is. So if you're not careful, you may think that there's no temperature. So with interval scale of measurement, normally there's no meaningful zero. So this is one of the main difference between the interval scale of measurement and the ratio scale of measurement, right? Now, another description of a data set can be, we can also have a univariate data, right? So a univariate data is when a single variable is measured on each experimental unit. So assuming I want to make an analysis with only this kind of variable for each of the observations that I have here, then this is going to be what? A univariate data. If I extend it to 2, right, then I'm going to have a bivariate data. So a bivariate data is when two variables are measured on each of the experimental units. So if I want to analyze only these two sets of data for each of the observations, then I have a bivariate data. If I extend it to 3 or more, then I'm going to have what? A multivariate data, right? So that's another class of data that we have. We can also have cross-sectional data. A cross-sectional data observations that come from different individuals or groups at a single point in time. So this can be a cross-sectional data because I've collected all of this information from different individuals or groups at the same time, right? In other words, we can say cross-sectional data are data collected on different groups or individuals at the same time. So let's pick an example. I have an example here. Let's say these are the profit earned by networking companies in a particular year. So this is going to be a cross-sectional data, right? Because these individuals are different. We have MTN, Vodafone, Tigo, Airtel. These are different groups, but you are collecting at the same time in a particular year. Now, what if I want to find the monthly profit, or let's say the daily profit or the weekly profit of only MTN company? Then that's going to give me another type of data set known as time series data. So let me scroll down. Assuming I have this as the monthly profit earned by Vodafone, or let's say MTN Ghana in a particular for a month, right? So these are monthly profits earned by MTN company. This is going to be a time series data, right? So when we talk about time series data, we are talking about observations that are collected at usually discrete and equally spaced time intervals, right? That is going to be a time series data. In other words, we can say these are data collected on the same individual at different points in time, right? So we have monthly profit. Now you have to know that if, for instance, I change this time domain to, let's say, 4, this is not going to be a time series data because the difference intervals of the time intervals is not equally spaced. If you take the difference between this right? You are going to get 1. If you take the difference between this and that, you are going to get 2. If you take the difference between this and that, you are going to get 0. So because they are not equally spaced, you can classify this as a time series data. So for time series, the time domain must be discrete and equally spaced, but with a response, it can be continuous, right? Now, when we combine time series data and cross-sectional data, we have another type of data known as the panel, longitudinal, or pooled data, right? So let me show you an example here. So this is a combination of time series data and um, cross-sectional data. So when we talk about the panel, longitudinal, or the pooled data, it is a process where data are collected on different individuals or groups at usually discrete and equally spaced time intervals. So if you look at this, we have different individuals, and the time domain is discrete and equally spaced. So this one, we are looking at the profit earned by networking companies from 2016 to 2021. So this one is for MTN, this one is for Vodafone, and the time domain for MTN is the same as the time domain for Vodafone, is the same as the time domain for Tigo. It is the time domain is the same for each of the networking companies. So this is going to be a typical example of what panel, longitudinal, or pool data. Now let's go back to our initial data set. So we still want to continue with the basic concept of a data set. We have identified an individual. We have identified what a variable is. Now the next concept, or yes, the next basic concept that we may come across in statistics is known as a population. So a population refers to an entire collection of individuals from which we may collect data. So assuming these are the total number of students in a particular college, then this is going to be my population, right? So a population can be of any size, but you have to note that the members of the population must possess at least one common or measurable feature. That's something that you have to take note of. So if suppose these are the total number of students in a college, and these are the information that I've taken from them, then this is going to be about my population, right? Now the numerical descriptive measure obtained by using all the data values from the population or in the population is what we term as a parameter. So assuming I want to find the mean age, right? I want to find the mean age, so I'll say sum, right, from B2 to B16, right? And divide by 15 because we have 15 of them. This is going to be the mean age. So if these are the total number of students in the college, and I'm trying to find their numerical descriptive measure by using all the data values in here, then this is going to be a parameter. So a parameter is a numerical descriptive measure obtained by using all the data values in the population. So if I compute the height, the mean height, I'm going to get another what parameter, right? I can also find that for the categorical variable as well. So, but we need to know that, as I've already mentioned, a population can be of any size, right? So you can have a population of, let's say, 5,000, 10 million, 1 billion, trillion, and I'm not sure you would like to waste all your time and resources in analyzing such a data. You would like to at least pick some elements from this population and use its information to reflect the characteristics from the population, right? So this leads us to another concept in statistics known as a sample. So a sample refers to a group of units selected from the population that is representative of the characteristics of the population, right? So I don't want to use, assuming these are too many for me, I don't want to use all the information here, I don't want to use all the observations. I have to pick some element in here to, and later use the information obtained from that sample to reflect the characteristics in here, and that's a sample. But we have different techniques in selecting the element in here. We have the probability sampling and we have the non-probability sampling, of which I'm going to do a separate video on them, right? But so let's assume I'm using the probability sampling like the simple random sampling, which gives an equal chance for each element to be selected. Assuming I've used a simple random sampling to get this observation. So using simple random sampling, I've obtained the third observation, the 5th, the 15th, 9th, and 12th. This is going to be what my sample. So this is coming from the bigger set, which is the population, right? So um, that's a sample. Now, suppose I want to find the mean age in the sample, right? Then I'm going to say sum from B T1 31 to B um, 35, right? And divide by 5 because we have only 5 observations. So this is going to be my numerical descriptive measure. Now, because this is coming from a sample, the name given to this numerical descriptive measure is known as statistic. So when we talk of statistic, it refers to the numerical descriptive measure obtained by using all the data values in the sample. So this is a statistic. I can also find the height. I'll get another statistic, right? So having two or more statistics is known as what? Statistics. And this is why we study statistics, because it is believed that the population is too large to basically analyze from. So why don't we pick some elements from the population and later use the information obtained from the sample to reflect the characteristics in the population? So this is why we are studying statistics, right? So you have to know that we also have two types of statistics, right? We have the descriptive statistics and we have the inferential statistics, right? These are the two main statistics that we have. With a descriptive statistic, this is an example of descriptive statistics. Descriptive statistics consist of the organization, presentation, and summarization of data in an informative way. In other words, this normally includes tabular presentation, graphical presentation, numerical summary. So this is an example of numerical summary. I'm just summarizing the mean age here. So it's an example of a descriptive statistic. I can also decide to summarize this data by using graphs. So that is the graphical summary, right? Instead of using numerical summary, which is a descriptive statistic, I can also decide to use a graphical way to describe my data. So because this is continuous or it's quantitative, I'm supposed to make use of quantitative graphs. We have graphs for quantitative variables and we have graphs for qualitative. I'm also going to do a separate video on that. This is just a brief introductory lecture. So I just want to just highlight on the some basic concepts. So because this is continuous or it's quantitative, I'm going to make use of histogram, right? So this is just going to be so this is going to be the graph, right? Right. So because it's continuous, so instead of me using the numerical summary, I can use the graph to basically describe it, right? For the qualitative variable, because it's qualitative, let me go to gender, for instance. I can make use of the let's say the bar graph, right? Because this one is too small, we don't see much of the graphs, right? So basically, you have to know that we have graphs for quantitative variables and we have graphs for qualitative variables. I'm going to do a separate videos on them, right? But just take note of that. So that's with the descriptive statistics. So the other type of statistics is the inferential statistics. This basically shows how information contained in a sample can be used to make inferences about the characteristics of the population. With inferential statistics, it normally involves estimation, hypothesis testing, prediction, and determination of relationship among variables. For instance, someone can make a claim that he or she believes that the mean population age, right, is let's say 25, right? But looking at our sample that we have a mean age of let's say 20. So we are supposed to test the claim that the person is trying to make to see if what we have here is significantly different from what the hypothesized value that the person is claiming about, right? So that is inferential statistics. I think we will be delving into that in our subsequent tutorials. So I think this is just a brief introductory lecture on statistics, and I think this will bring us to the end of today's tutorial. So please, in our next tutorial, we'll be looking at the flow diagram or chart for classifying data. As I've already mentioned, knowing the structure of the data set is very important. So we want to know the flow chart or diagram for classifying data and later look at the structure of a dataset for some statistical methods. So please, if you find value in this video, don't forget to subscribe if you have not, and also click on the notification bell to get more updates. Thank you for watching.